Hello everybody. In this video we are going to define the coordinate ring on the affine n-space a to the n, and we are going to see how to extend the definition of the coordinate ring to every affine algebraic subset of a to the n. So let's begin with the coordinate ring on a to the n. Well, this is basically just the ring of functions you get from plugging in points of a to the n into polynomials. So let me give you an example. If you have a polynomial f, which is a polynomial in x1 to xn, then you can of course plug in a point of a to the n. Let's say this is called a1 to an. So you plug this in this polynomial and you get a value, you get a number, so which is an element of the field. So let's say this is called, well, doesn't matter, let's say this is called y. So this polynomial evaluated at the point a1 to an gives this number y. So we have a function that works like you give me a point in a to the n and I plug it into my polynomial and I get a value in the field. And thus this polynomial determines a function. And of course by adding pointwise, we can add such functions and we can multiply them and we get a ring of functions on a to the n. And this ring of functions is called k of a to the n, which is the coordinate ring of a to the n. And now we want to extend this simple definition to every affine algebraic subset of an. And to do this, we note that if two functions agree on v, so I mean if we have polynomials f and g such that this function f, where you plug in points of an, is equal to g, where you plug in points of an, for all a1 to an in v. So if these polynomials as functions on a to the n agree on v, then we have that f minus g is an element of the ideal of v. Remember, the ideal of v contains the polynomials that vanish on v. So if f and g agree on v, then f minus g is 0 on v. So f minus g is an element of I of v. So this characterizes such pairs of functions that agree on v, and we can use this to define the coordinate ring on v simply by saying that the coordinate ring on V, which we denote by K of V, is the coordinate ring of a to the n, where you mod out by this. Oh, I'm sorry, I hit the wrong button here. Where you mod out this coordinate ring of a to the n by this ideal I of V. And this means that the elements of this coordinate ring look like this: F plus IV, and these elements or these representatives correspond to functions f and g restricted to these affine algebraic sets V.